Hi, welcome. This talk is about the poster called The Smartphone as a Hydrophone. As you may know, smartphones are powerful tools to perform physics experiments everywhere, even underwater, thanks to the modern waterproof smartphones. So here we are proposing two experiments. One about the speed of sound in water by the simple time of flight method, and the second experiment about the acoustic location of a sound source. For this experiment, we need two smartphones, obviously one of them waterproof, and the first step is to synchronize the smartphones. For this purpose, obviously we need an app able to record sound. So we start to recording and we generate a sound pulse, for example, with two metal bars, with the microphone of the smartphones close together. Then, without stopping recording, we separate the waterproof smartphone. Here is a smartphone V. Then we submerge the smartphone with a roller or a tape. We measure the distance between the microphones and we generate a second pulse in the surface of the water. So we have two pulses. Then we have to analyze the signals. We could analyze with a sound editor in the smartphone or in a computer, for example, using the Audacity software that is free and very easy to use. So the first step is to synchronize the signals. For example, moving signal V until the first pulse in both smartphones are at the same time. Then we have to look for the second pulse. For the smartphone A in air is simple, but it's not so easy for the smartphone B underwater because of the huge noise. Take a look here of the sound underwater. The signal is very noisy. So we measure the time difference here in samples of the signal. Here in this real measure, we have 82 samples. And as we know, the sampling frequency, that is 44.1 kilohertz, we obtain the time difference in milliseconds, 1.9. Then we obtain the speed of sound in water, that is 1.6 kilometers per second. The second experiment is about the acoustic location of a sound source. There is a classic problem that says that an explosion occurs in the ocean. Then the sound waves of the explosion travel through water and air with different speeds, arriving to the microphone and the hydrophone of a ship with a time difference delta t. So knowing the speed of sound in air and the speed of sound in water, we could obtain the distance of the explosion to the ship. We could perform this problem as an experimental problem with two smartphones again, synchronizing them Then, at the same distance of the smartphone A, we just submerge the smartphone B. Then we generate a second pulse, and with a procedure similar to the first experiment, we measure the samples difference, in this case 258 samples, or 5.9 milliseconds. From this time difference and knowing the speed of sound in air and in water, we obtain the distance from the sound pulse to the smartphones, in this case 2.66 meters. That is very similar to the direct measurement made with the tape. In conclusion, we have two simple and inexpensive experiments about underwater acoustics, a topic that is generally little explored experimentally, that could be fun and engaging for students. Finally, we point out that it's important to take care about the noise and the uncertainties, 2 points that will be interesting to discuss in class. Thank you for your attention. Please visit our website, Smarter Physics, where we have a lot of papers and references and projects about physics with smartphones and other modern technologies. Thank you again. Have a nice day.